The last method that we will look at for solving systems of equations is the elimination method. And like the substitution method, you do get a solution, a coordinate. That coordinate represents where these two lines cross. But again, like the substitution method, you don't actually see a graph of these two lines when you get the coordinate. You just solve it algebraically, and you do not graphically see where these lines cross. You just have a coordinate for where they cross at. So it's pretty interesting in that regard. Now, whenever we do elimination, you have to either eliminate x or y. Choose one of the variables to eliminate. In order for that variable to eliminate, you may have to multiply one of the equations or both of the equations by a number, so that the coefficients for the variable that you choose to eliminate are the same, but they have different signs. Like y, for instance, in the two equations that we're looking at. Y in the first equation is 1y. In the second equation, it's negative 1y. Okay, it doesn't have a number in front of it, so we assume that it's 1, right? Well, because these numbers are all, I'm going to choose to eliminate y. Because they are the same number but different signs, I actually do not have to multiply either of these equations by anything, because what I do once they have the same number and different signs, I add the two equations together. So 2 plus 1x is 3x's. And what happens here, the y's cancel. That's why I need them to be the same number and different signs. Okay, and then 2 plus 7 is 9. And then I can solve for x. Okay, so far, this is my solution. Okay, I just need the y. Once you have x, we can substitute it into one of the equations. I think it looks easiest to substitute it into the bottom equation, x minus y equals 7. So I can say that, well, x is 3, so 3 minus y equals 7. I can subtract 3 from both sides and get 4 equals negative y. So therefore, we can divide by negative 1 and get that y equals negative 4.